Hi, I'm Chung from University of Reading. I will talk about a mini research process approach for econometrics module. All right. Now, in the UK, most of the universities offer MSc Economics program. And in the MSc Economics program, basically students have to write a dissertation as a capstone in summer term. And in the first 2 semesters, basically university will offer some econometrics module for them. So for these modules, basically they would cover a learning outcome like this one, like applying econometrics techniques with computer packages and with real-world data and so on. But when we teach econometrics, it's quite happy to use a textbook data set and published paper data set to demonstrate the techniques. However, when students write the dissertation, okay, they will find that it's quite often they have to deal with raw data set. Then they face many different problems because they have to find the relevant variables for their estimation. They have to clean the data. They have to do some transformation in the data so that they can really use it. So what I did is I tried to use bridge this gap between raw data set and applied econometrics with a mini research process. So I'll try to use raw data set and try to integrate computer lab sections with the formative mini project assessments to help the students to develop the skills so that they can start from a raw data set when they do their own research. Okay. My module is Econometrics 1 for an MSc Economics program. It's in autumn term is the first module in econometrics for the program, and I cover standard materials like OLS, two-stage least square, limited dependent variable models, and so on. Students have completed their undergraduate degree in economics or closely related subjects. Okay. Context. Now, the teaching arrangement is face-to-face, and we have 10 2-hour lectures, 8 1-hour computer lab sections, and the class size is rather small because this is a small cohort, and we have quite a few auditing students and some new PhD students. Okay, they would like to refresh their memory on econometrics techniques, and for assessments, we have 1 individual project and 1 final examination. Okay, the key thing, the mini project approach. Now, what's that? So basically, I ask the students to do to answer a research question in the computer lab sections, and another research question in the project for the project assessment, but with the same data set. Now, what does it mean? That means in all the computer lab sections, we come together and discuss and work together on a research question with the raw data set. And the raw data set would be the same that they have to use for their project. But for their project, the research question is similar, but not the same. So the advantage of doing this is, okay, it provides incentive for the students to participate and work together in the computer lab section so that they can learn, they can develop the skills together and discuss together. And they can also easily transfer the learned skills from the computer lab sections, okay, on handling raw data to their project. And then in the class, okay, in the computer lab sections, I keep discussing with them on how to build up their model from scratch, okay, to answer the research question so that they can know in this process, by my feedback, they know the requirements of the project for the module, and they also know in case they want to do a research for the dissertation or a real research, what's the requirements? What do they need to care about? So the process is from learning the skill in the computer lab sections to practice them in the project for my module, and then to the dissertation to apply them. Okay, in the computer lab sections, the research question that we discuss is, does place of birth affect income? Now, it's not really a topic for publishing paper. It's just a topic that, for research so that students can gain some experience. So in the computer lab sections, there are totally 8 sections. In the first 4 sections, we talk about, we discuss how to generate the variables. We look at the user guides, find the relevant variables for our estimation. What are the x? What is the x? What are the x on the right hand side? What is the y on the model, and so on. Okay, we choose variables, transform them so that we can use them. And in the last 4 sections, we perform the estimation, the tests, and then discuss and interpret the results. So students work in groups and pairs. It's a small class, so we have 2 to 3 groups in each section. Okay, it's flexible for them. It's just they just work together, and we explain that discuss in class. The dataset we use is the 2013 annual population survey from the UK Office of National Statistics. I uploaded the dataset and the user guide on the Blackboard so that they can get the user guide and the dataset easily. Now, just an example. So for example, like what is the X on the right-hand side? Now, we all know that to do an estimation like this, we expect education level have to be controlled. In most of textbook, education is measured as the year of schooling. But in our data set, there are many variables capturing something like education or qualifications or something like that. After discussion, we think that this variable, highest qualification in detailed grouping, is the best for us. For answering our research question, but it's not in years of schooling. We can see that just like what we see here, it's not years of schooling. Instead, is different categories, okay, of education level. Okay, so what can we do? Moreover, there was some answer like no answer or did not know. So we have to transform them into missing or something. So these things, these problems that we face cannot be, they will face some problems like this in raw data set, right? So we have to transform them, like changing the no answer or did not know into missing. We have to use dummy variables on the right hand side and so on. These are something that we discuss in class. Okay, and then the project. In the project, they answer a similar question. Do females earn less than males? If so, by how much? Now, this question is not a research question for publication. So I do not use the term discrimination because I don't want to draw them into that literature. Just focus on the econometric techniques that we covered in class. Okay, so I expect the students to generate the variables, okay, by themselves, perform estimations, okay, justify the method, and critically review their results. And there is some flexibility because they can choose the measurement of income by themselves. They can choose the X on the right-hand side. Okay, different students have different methods and different choice of variables, so it is flexible. Okay, my message to them is not really is a project, but the result will never be perfect. But they have to be aware of the limitation or the potential problems when they do the estimation. Students' performance generally good. They participated in the discussion in class quite actively. The project, basically, they could answer the question with the data set, okay, with reasonable results. Okay, I think is quite good. Now, for evaluation, now the sample size is actually very small because it's a very small class. We have only 5 answered evaluation. But anyway, they're quite satisfied with the module. They think that it's well organized. Out of 5, okay, the score is 5. It's basically full marks. They think it's interesting. They think the teaching is interesting, and they think they know the requirement of the assessment, including the project, and they satisfy the module. And more importantly, by the written comments, they write that this module helped them a lot in the dissertation. That's good. And that's what I want, actually. And they also think that the PC classes are well organized and helping the course. That's good. I also think that my module is very practical, very engaging. That's actually what I want, because I don't want to have an econometrics module. After studying, they don't know what to do with their project or dissertation, right? That's what I want. Okay. Okay, that's all. Thank you.
Hi everyone, and I'm excited to present to you on how we're leveraging Tableau for data visualization and analysis in our large lecture statistics courses. So motivation, a lot of this stems from talking to our students. And so on the left, you'll see a survey that we asked our seniors here, basically like what technology we're using. And two big things that popped up were visualization. There's just a huge growth in data utilization. Like the chart on the right just shows number of analytics / data science master's programs. They've exploded. And so we're just kind of responding really to the demand of our students. And how I kind of motivate it is I kind of show this, like, listen, like 90% of the world's data was created in the last 2 years. Every 60 seconds, 400 hours of videos are uploaded to YouTube, or around 700,000 hours of videos are watched. That's just YouTube. Look at Facebook, Google, Twitter, and like all these programs that they're using. This is happening every 60 seconds, and we need people to leverage it, utilize it. Other ways that we motivate the students, you have this really sort of messy initial data, then you've got to clean it and sort it, arrange it, and then present it visually. And then the big thing is, right, what's the story behind it, right? Explain. One big question that we get a lot is like, well, why Tableau? Number one is it's free. It's also consistent across Macs and PCs. We also like that rather than just saying on their resume experience in Tableau, they can show their visuals, they can link to it on their resume. Another big thing is like, hey, like it's owned by Salesforce. It's a major program. So the last one is happenstance. Here is the Tableau public of Christian Felix. He's actually someone that graduated from Eller with a master's and had been playing around with Tableau and actually had reached out 3 or 4 years ago and said, hey, like I'm interested in data visualization. I think students could really benefit from it. Can I come teach workshops? We met with him, and you can see all of the amazing things that he's kind of built on his Tableau public profile. And so he actually helped us build the 3 cases based upon what we were teaching in the class, our student level, and things that he thought would be really useful. Just a quick overview of the course that this is in. It is a second sequence business statistics course. It's 4 credits, 3 of which are lecture. 1 is a lab discussion. That's really important for us. Each semester we'll have between 175 to 330 per section. We have at least 2 sections per year. Sometimes we have per semester. It is required for all business majors except for our BA Econ. It's primarily taken by second semester sophomores. So we do have selection in there. Okay, so how we've implemented. We have 3 of these discussion assignments that are centered around Tableau. The first discussion assignment is just getting students started. This is a big thing in terms of making sure they can get the program downloaded and get access to it. So then when we actually get to the first quote unquote real assignment where they do testing and they prove a difference or conclude that there is a difference, and then the visual is just to show that, right? Because people like visuals. There's then another one where it's data exploration. So they explore data to say like, oh, what testing should we do? And then the last one is just, hey, like you've got a really messy data set. We want you to think about all the different ways that you could use it. And so it's just play around with the data, pull out some insights, and tell a story using that. And so now I'll show you like an example of what one of these looks like. Here's the assignment that they get. COVID has impacted us a lot. And so we deliver these both in person. We also offer a pre-recorded version that walks through all of the steps. Right? Every time we start with like, all right, get this kind of organized, what it is. And then there's always a scenario, right? Why are you doing this? And what are you doing? And then it's just, okay, what do you need to do to get full credit? We kind of have these check boxes with the visuals. These are specific to each one. And then how to save it and get credit. So we walk them through these steps, and I'd be more than happy to share a lot of this with you. And then at the end of every single one is a best practices. All right, but this is just get them primed because they have never visualized data. They don't know what's clean, what's professional when they're kind of going through this, and they get better as you go through them. I've already kind of talked about these, but we have a live and pre-recorded version. We do all the work for them, right? They don't leave having to do anything besides that kind of professional checklist and write about the results, right? So they don't have to build any visuals on their own. And then to grade them, they have to submit a link, right? They can't submit screenshots or anything like that, but it has to be a link to their public profile. outside of these three, we also have a data visualization role for a final group project where they can go through and do that, where we don't actually build all the visuals for that one. We just provide a best practices pre-recorded training that they can use. Let's just show you examples. So here's a student that he actually was an undergrad the first semester we did this, who ultimately went on to win the Tableau Iron Viz for the student edition. But you'll notice like his first one, right, just simple bar graph, and it doesn't look super great. To me, kind of the text is a little bit small, but like you see they get progressively better. And so here is, he went a little bit, got creative and said, okay, I want the map and the things over here. And then he actually used a filter instead, which, and then his last one was here, the store selection, where again, like these can be variable sort of however you want it. He kind of spent a lot of time on these, but like looks at Abercrombie and things like that. But he did a bunch of different ones. Okay, Danny's another former student, right? So he has these, the three where he's kind of a more digitally or graphic design person, where he kind of goes through and does that. But like he can just link this, and we've had multiple students come back and say like, oh, I pulled up my Tableau public profile and I showed them what I did, and then almost an immediate turnaround, they got a job offer. Same thing, like another student here, they have all three, and we've actually incorporated a new one into our prerequisite class. We're still experimenting with this, but it's only pre-recorded, so there's no actually live version of this, but where they're kind of getting experience with these, and you can kind of see the functionality. I think this is something that they built for their final group project. And again, students are so creative sometimes. Like, so they're working with Amazon to look at data, and like they have these buttons where you can click, you can go look, and they use the leverage, like the basic things. So like there's the overview, and there's like, okay, let's look at profit and discount graph analysis. It's like the visuals are simple, but it looks nice, which is really what we're looking for. And they have the different ones that they go through. Okay, so that was the good. Here's the bad. There are issues, right? It's inevitable with any form of technology. The first question you have to answer is, well, which one do I use? So there's three versions for students. Which ones are free? There's Tableau Public, where you download an app and you can use that. There's Tableau Public, an online version. We have pushed away from this because it's very reliant on internet and it doesn't have the functionality. Then there's Tableau Desktop. So all these are free. I can talk about some issues. So Tableau Public, you cannot save it locally. You can only save it to the internet, and students forget. And so they'll go the whole discussion assignment, or they'll work for 3 hours on their final group project, and then they'll try and save it, and it will crash, and they'll lose everything. We actually like Tableau Public, the app version, but then we say like save often. Because once you save it, you can get back to wherever it is. Just you have to be connected to the internet. Tableau Desktop is better in the sense that you can save it locally to your computer. You don't need the internet. But to save it to your online profile, you then have to create an online profile, so a separate step. And there's an extra step like that you have to extract data to save online there. That's just more work for the student. Tableau Desktop will connect to more data sources, but you only get rolling 1-year licenses. So Tableau Public is free for everyone all the time. So you can use it right now, whether you're a student, academic, or not. Desktop is only free for students, academics, and select groups, and you have to like apply for a license every year, which can get kind of frustrating. Then there's saving, submitting, general issues. So my biggest drawback on Tableau is it doesn't have spell check. And internet reliability, like we have, again, 300 students in a room at once. The internet can get kind of stressed and cause issues. Sometimes different computers don't like the security settings. If you're working on Tableau Desktop, there's this data extract requirement. There was a new issue this semester after updates that they had the visual, it just wouldn't render, so we couldn't see it. And so they had to save it again under a new name. One common thing is students will submit that first assignment of the 3, and then they'll assume, well, they have the link to my other one, so all I got to do is save it on there, and then they know. The problem is 600 students, I can't go back to different folders to try and find the different ones. I'm sure there are others that I'm forgetting. They're small, but they do add up. Grading's pretty easy. It can get a little bit subjective without guidance. So you got to be really clear in the grading, which I think is true. I hope this was helpful. And if you're interested in seeing our assignments, talking more, feel free to contact.
Hi, my name is Theodore Svoronos. I'm a lecturer in public policy at the Harvard Kennedy School. I teach in the first-year quantitative method sequence for Masters in Public Policy students. And today I'm going to talk to you about how we've used Google Colab to introduce students to the language of R in a way that I think is pretty frictionless and pretty easy to do for the vast majority of students. Now, before we get started, I want to say that I'm presenting this alongside Sharid Goyal, who is really the thought partner and the fellow faculty member teaching this course with me. And I want to also give special thanks to Jonathan Bork, who is the third faculty member teaching in this course, and then Dan Levy, who doesn't teach in this particular course, but has really helped us think through how to teach R to public policy students in a way that's compelling and effective. So I'm going to start by giving you a bit of context. So this was for first-year Masters in Public Policy students. There are about 190 of them. And the one thing that they all have in common is that they're all pretty different. So there's vast heterogeneity in their backgrounds, their interests, their goals, and subsequently what they actually want to get out of this course with us. And as far as background goes, about 13% had never taken a stats class before of any kind. And 42% had never taken a course involving programming of any kind. So as you can see, there's quite a bit of variation, but particularly in coding, there were a very large number of students who had never even thought about how to actually code in a way in a formal classroom setting. So the goals of the course, broadly speaking, were to equip students with tools, the tools of descriptive analysis, probability and decision analysis, statistical inference, but in a way that was really focused on solving big policy problems. So we really focused on the applications of these tools and also on how we can communicate them effectively to folks who might not be technically adept or previously exposed to statistical tools. And then finally, perhaps most importantly to this talk, our goal was to introduce coding as a way not just to sort of get used to using data, but as a way to think about how data is constructed and how to think about statistical analysis more generally. So the goal wasn't to make really strong coders in just a semester. The goal was to introduce them to the importance of coding in a way that was effective. Now, as we thought about how to do it, the big challenge that we faced is simply that learning to code is hard. And by hard, I don't just mean it's difficult to get your syntax right and all of that. There's just a lot of prerequisites required to even get started coding. So before you can even code, you've got to think about, is my coding environment set up? Do I have the right data set loaded? Are there the correct packages installed to actually manipulate that data? If I have a problem set or prompt or something like that, I have to flip back and forth between my code and the actual problem set. And then finally, if I have text, prose, and code, how do I intermingle them in a way that's effective? So we took a lot of inspiration from Mina Setinkaya Rundle, who has a really great talk called Let Them Eat Cake First. And her basic thesis is that if you want students to be excited about coding, you've got to give them the good stuff as early as possible. And by the good stuff, I mean actually doing analyses, creating visuals, things along those lines. And so it was very important to her that you not spend a huge amount of time installing R, getting your working directory set and all of that. Instead, get people actually coding interesting things as quickly as possible. Now, she suggested using RStudio Cloud, which is now called Posit Cloud, to do this, which essentially gives you an interactive RStudio environment within a browser. So this actually solves a lot of the problems that we were first talking about. Specifically, it allows for preloading data, preloading packages, preloading code for students to work with, and it's entirely cloud-based, so you don't have to worry about making sure that your R environment is installed locally and things like that. However, there were some shortcomings with this that we encountered, the first of which is that at least now, using Posit Cloud in a classroom setting is actually quite expensive if you want to do so in a large scale. And secondly, if you want to intersperse text and code in a way that's sort of effective, you really have to get used to R Markdown. And for us, R Markdown, for students, most of whom I would say are not even going to be going on to actually use R Markdown to knit PDFs, we found that as an additional burden rather than a skill that we wanted them to come away with that got in the way of actually getting used to the syntax of R. So that's why we decided to start using Google Colab, which is a combination of Jupyter Notebooks and this tool, Google Collaboratory. Jupyter Notebooks, for those not familiar, is essentially an interactive environment that gives you a document. And those documents are cell-based, and you can have text cells, you can have data cells, you can have output of that data of the coding cells, and it basically lets you intersperse code and text in a way that doesn't require you to, for example, have a knitting environment to be able to create a PDF. And Google Colab is simply a cloud-based Jupyter notebook environment. So it's hosted on Google servers. The notebooks can be stored on Google Drive or even GitHub, and you can basically work with these notebooks interactively using Google Colab. So I'm going to show you what that looks like in a second, but first I want to talk to you a bit about the big advantages we saw of using Google Colab. The first is that it's free. For our uses, the amount of actual data we were asking students to work with, we didn't need to pay anything to be able to get Colab working. Plus, it was in an environment that students were used to, Google. There's also no local installations necessary, which is quite nice. And the notebooks themselves intersperse text and code, but it keeps them discrete in these code blocks or these cells that I'll tell you about, which lets you kind of separate out your text and your code in a way that's effective. Code blocks can be pre-populated with what we call starter code to help people get started, and then packages and datasets can be loaded at the start of the notebook so students don't have to worry about them going forward. So rather than get into the details of this, I want to actually show you a demo of this in the form of this Google Colab notebook, and you can access this yourself by going to bit.ly/colabdemo. So I'm going to show that to you now. So here's what a Colab notebook looks like. As you can see, we have all these different text cells, and you can double-click into a text cell to get the formatting options. Here are some instructions that we provide students to for every problem set about saving a copy of this to their own drive and inserting images and things like that. So we'll click Copy to Drive to make sure it gets copied to their own Google Drive. And at the beginning of every problem set, we have this little block that says, run this code cell. Now you can see, I'll zoom in a bit. In this case, we're asking them to load the tidyverse, set the seed, and we manually construct 2 data frames that they're going to use for different parts of this problem set. You can also actually load actual data sets via URL, for example. So we start by asking them to simply click that cell. And once that runs and everything's loaded, they can go on and don't have to worry about anything related to data input and things like that. So we start by talking about teleworking during the pandemic. We would normally show them a table, but we actually ask them to run this cell instead. And by doing so, we both give them the data that they need and also show them how the data was actually compiled into this table, which is nice. We start by asking them to simply use R as a calculator. And so in this case, we'll use the data from this table to answer this question. And we simply click Run to get the right number. We can then have them actually input text. And it renders nicely. And then we ask them to actually use the mean command, the actual telework data. And as you can see, it auto-populates from the data set. So we use that to get the same number. There are a number of other questions in this notebook, including the construction of histograms, so you can see how graphs get shown as well in Colab. So this is kind of high level what the big benefits of Colab are. The disadvantages I want to make clear. First of all, students aren't actually practicing loading data sets. So at some point, if you want students to get comfortable doing that, you can either teach it to them in Colab, which is a little harder, or switch them over to RStudio. It does require an internet connection. And if you want to install non-standard packages, so in this case, tidyverse was easy to draw from, but if you have other packages, it could take time to install. There's some minimal troubleshooting required. Usually, vast majority of the time was simply telling students to make sure that they ran all the cells before the cell that they ran to make sure that everything was loading. Inserting images and exporting as PDF can also be a bit cumbersome, which I'll talk about in a second, but I want to finally point you to a couple of useful tools that I think can be helpful in this case. So the first is this Chrome extension called Go Full Page, which simply takes your whole notebook and exports it as a single image PDF or as a single image. And so that deals with exporting as PDF very easily. Freeimage.host is just a website where you could upload an image and then it creates a markdown link for you. That's only if you want people to insert, for example, images of their handwriting or things like that. And then there are 2 AI tools that I want to point you to, codesquire.ai, which currently works to kind of give students some assistance in their code writing. And Google's about to introduce their own in Colab called Cody to be able to help students in that regard. So I hope this was an effective way to kind of get a sense of how Colab works. I highly recommend trying it, particularly if you want to get students coding immediately for the first time in a way that's free, accessible, and pretty easy to do.